Now we will see some problems based on notches and weirs. So first problem says that water flows over a rectangular weir of 1 meter width at a depth of 150 mm and afterwards passes through a triangular right angled weir taking CD for the rectangular and triangular weir as 0.62 and 0.59 respectively. Find the depth over the triangular weir. So let's see one by one. So for the rectangular weir, in the problem it's given as L is equal to 1 meter. Depth of water is given as 150 mm, which is 0.15 meters. CD is given as 0.62. This is for the rectangular weir. Again for the triangular weir, it is given as right angled. That means theta is equal to 90 degree and CD is equal to 0.59. So consider that depth over the triangular weir is H1. That is the quantity which we have to find out. Find the depth over the triangular weir. We have to find out the discharge over the rectangular weir first. So the equation, right? Q is equal to 2 by 3 into CD into L into square root of 2G into H raised to 3 by 2. We have all the quantities CD, L and capital H. So answer comes to 0.10635 meter cube per second. Unit of discharge is meter cube per second. Same discharge passes through the triangular right angled weir. So Q has a different equation for triangular weir, that is Q is equal to 8 by 15 into CD into tan theta by 2 into square root of 2G into H raised to 5 by 2. Here the quantity unknown to us is H, which is H1, right? So substituting all the other quantities, we know Q from here, Q we know, CD we know, theta is also known to us. So finally we get H1 is equal to 0.3572 meters. So moving to the second problem, water flows through a triangular right angled weir first and then over a rectangular weir of 1 meter width. The discharge coefficients of the triangular and rectangular weirs are 0.6 and 0.7 respectively. That is CD. If the depth of water over the triangular weir is 360 mm, find the depth of water over the rectangular weir. This is similar to the last problem, except that the positions of the triangular and rectangular weir are interchanged. Here first water flows through the triangular weir, then through the rectangular weir. So these quantities are given. First we have to find out the discharge through the triangular weir, which is 0.1102 meter cube per second. Then we have the same discharge passing over the rectangular weir. So substituting all the other quantities except capital H, we have capital H is equal to 141.5 mm. So moving on to the third problem. A weir 36 meters long is divided into 12 equal bays by vertical posts, each 60 centimeter wide. Determine the discharge over the weir if the head over the crest is 1.2 meters and velocity of approach is 2 meters per second. So we will see. Length of the weir is given as 36 meters. Number of bays, that is the number of portions into which the weir is divided, is 12. So number of posts is 11. That is, if this is the weir over which the water is flowing, it is divided into sections. How many sections? 12 sections. So to divide it into 12 sections, you need 11 vertical posts. This is one vertical post. Like this, you have 11 vertical posts which divide the weir into 12 bays. Okay, so width of each post is given as 60 centimeters or 0.6 meters. So effective length of the weir becomes L is equal to L1 minus 11 into 0.6. That is, the width of the vertical post is reduced from the width of the weir. That is, we are considering the length only through which the water is flowing. Water cannot flow through the post. So L1 minus 11 into 0.6, which becomes 36 minus 6.6, which is 29.4 meters. Head on the weir, that is water level above the weir, is 1.2 meters. This is given in the question. And velocity of approach is also given in the question as VA is equal to 2 meters per second. So HA is given by the equation VA square by 2G. This we know already. So substituting the value of VA and G, we get HA is equal to 0.2038 meters. So after that, here we know that the weir has end contractions. Right? How many end contractions? 2 end contractions. So N is equal to 2 into 12. That is 2 contractions for each bay. So total number of bays is 12. So total number of contractions becomes 24. So by Francis formula, we have Q is equal to 1.84 into L minus 0.1 into H. 0.1 into N into H actually. Because before in the derivation, we had the equation as L minus 0.2 into H. Right, L minus 0.2 into H. How 0.2 came into being is 0.1 into 2 into H. So here we have 0.1 into N, which is the number of end contractions. And again we are considering here the velocity of approach. So capital H is replaced by H plus HA. Into H plus HA the whole raised to 3 by 2 minus HA raised to 3 by 2. Final answer comes to 75.246 meter cube per second. The next problem, the heights of water on the upstream and downstream side of a submerged weir of 3 meter length are 20 centimeter and 10 centimeter respectively. If CD for free and drowned portions are 0.6 and 0.8 respectively, find the discharge over the weir. So let's see now. Height of the water on the upstream side is given as 20 centimeter or 0.2 meters. Height of the water on the downstream side is given as 10 centimeters or 0.1 meters. Coefficient of discharge are given as 0.6 at the upstream and 0.8 at the downstream. Okay, so total discharge is given by the equation Q1 plus Q2. So you have here Q1 and here you have Q2, and you know the values of CD, capital H and L, and also small h. So you can substitute and find out, and Q comes as 0.504 meter cube per second. So these are the problems to try out. Thank you.